Hey, thank you. So let me share a screen for you. So hi everyone. So my talk will be about why GraphQL is perfect for microservices. And in this talk, I'll be showing you several things. But before we're getting started with why you should use microservices or maybe why you shouldn't, because this talk won't be about why you should use microservices. But in case you have them, um, it will be a nice talk to see how you can use them with GraphQL. And to emphasize why I'm not saying you should or shouldn't use microservices, is I brought a meme for you today. So this is a nice one someone shared on Twitter, I believe. So when your boss tells you we're converting to microservices, and then in the end it will be all these sort of shipwrecks trying to bring all the containers on the shore instead of one giant monolith that brings the containers all efficiently. You now have I don't know, say 5 or 6 somehow shitty boats that trying to bring your containers to shore. So microservices aren't always efficient. So especially if you're a smaller company or if you're not serving that many customers, make sure to stay away from microservices. But if you have a fully distributed system and serving tons of customers, then microservices might be a thing for you. And if you have them, I'll be showing you how you can actually use them together with GraphQL. So before that, a little bit about myself. So, as was mentioned, my name is Roy. You can find me on Twitter with the handle @GetHackTeam. I'm a entrepreneur, software engineer. I speak at conferences and I write books about React or GraphQL. There is a new one coming up about React soon, as React 18 will be launched. Well, hopefully soon, somewhere in the next weeks or maybe next month. Day to day, I work with a company called StepSen and also my own company called HackTeam, in which I give trainings and workshops about GraphQL, React, TypeScript, all these kind of technologies. But to know more about me, just follow me on Twitter. And so, what do you already know about GraphQL? Well, probably a lot because we're at the GraphQL Meetup, of course. So, in this talk, I'll be skipping the parts about why you should use GraphQL or why GraphQL is really awesome. But I will be showing you why GraphQL is perfect for microservices because GraphQL is truly perfect for microservices. And a lot of microservices I saw, they were using REST or another protocol, or maybe not even really using a protocol to communicate between the services. And often these microservices would have an API gateway or a data layer or a service mesh or whatever you like to call them that sits on top of all these microservices and tries to route your data around. But you can do this more efficiently with GraphQL. And why is that? Because GraphQL is all about graphs. And as you probably have been using GraphQL before, you understand the graphs that make GraphQL cool, especially with recursive types. And whenever your query is trying to load multiple types that have relationship with each other, you really see that GraphQL is bringing a huge bonus point. And if you build your GraphQL server yourself, then probably you have to make sure that all your resolvers are either query resolvers or type resolvers or field resolvers. Um, that's something we'll be skipping for today because today we'll be talking about microservices and especially why they are great for GraphQL. And the biggest point for this is as GraphQL is thinking in graphs, microservices are really domain based. And I've seen a lot of microservices that were in domain based or were combining multiple domains into one. It's something I generally advise people not to do. Also brings me back to the point in the beginning. Like most companies probably don't even need microservices because they're not big enough in terms of users to actually need them, or they have a small development team. So why use microservices? And I think microservices are often added to a stack because developers like to build microservices, and also because people think it's needed for the servers or to keep things actually separated from each other. So if you decide to do microservices, make sure they are domain based. So you don't want microservices that overlap with each other or are dependent on one of another. Each microservices should be. I always say microservice is like a pure function. It should be aware of what comes in and what comes out, but it shouldn't be aware of what any of the other microservices are doing because microservices should be a service on its own that's domain based, has one single purpose, maybe multiple purposes, but always within the same domain. So if you would have a client that talks directly with a microservice and This is usually not the case because usually any microservice would have some sort of API layer, gateway, data layer, whatever you like to call them on top of it, that distributes routes from all these services to one client. But suppose you have a client that's talking with microservices, always make sure they have their own domain. And it's important to emphasize this, and I can't emphasize it enough. But each service should have its own domain. So make sure that's really the case for your application. So what does it look like? Something like this. So suppose you have a client, it has to get something from your authorization service, which is a microservice. So what it will do, it will probably call the API of that authorization service either directly or through some sort of mesh or gateway, and then that service will return the token. So that's the only thing that service should do. Probably that service should also validate the token, but that's something I'm not really showing in this setup. But probably your authentication service is only doing things related to authentication. So it's requesting tokens, then returning a token, probably validating it, or maybe creating new ones based on your probably creating new ones based on your refresh token. So those are the only things your out service should do. And then your client can take this token, it can send it to the user service, and the user service can validate it through the out service, or the client can validate it on its own. But what should be really clear from this is each service should have their own domain. And those domains shouldn't overlap. They should be tightly correlated, and not being overlapping with each other, especially not in this scenario. So these are all domain based. And then the nice thing, if you combine them with GraphQL, is that each microservice can have its own graph or schema in this case. So whenever you'll be using GraphQL for your microservices, it is advised to create a schema for every service. So every service should have their own schema. And then later on, there are multiple ways to bring them together in one schema. But first, let's have a look at those graphs. So suppose we have this setup again. We have authorization service, a user service, a post service. And the authorization service is just doing stuff with authorization, and the user service and post service are also domain based. And if you create graphs for this, you would have an authorization service, which should have a type maybe called auth or token or user. Not actually user, because user will be a user service. So the user service will have a user type, maybe an address type. I don't know, maybe something else. What else have we got besides addresses and user IDs and whatever that should be in that service. And then we would have a post service, which probably have a post type and then a query to get all the posts, maybe to get all the posts filtered by maybe something like an author or a keyword. And the same can be said for the users. It can also have some sort of filtering, but all these services should have their own graph. So when creating microservices for these REST services, in example, or whenever you're creating these microservices in GraphQL directly, always create a schema that is not reliant on any of the other schemas. So as the auth service is domain based, it shouldn't be aware of any user types. And the same can be said for the user service. As it's domain based, it shouldn't be aware of the post type, in example, of post it could be linked to as an author, or maybe as a contributor or editor, or wherever you like to connect them. So these domains truly are graphs, or as we're using GraphQL, there will be schemas. And whenever you're creating these microservices with GraphQL or REST, it doesn't really matter. Make sure they have one schema. And in REST, you can, of course, also create your Open API schema, and then you connect them through GraphQL later on, as I'll show in a demo. But just make sure the schemas are really domain-based. And then, of course, you can use GraphQL to bring them all together in one schema. So I already said microservices are typically not interacting with a client directly. Often it's being done through a gateway, data layer, or mesh, or whatever you like to call them. And the same can be said for GraphQL. And suppose we have some sort of data layer, then this data layer would be the perfect communication for this data layer would be GraphQL, of course. Because with GraphQL, you can combine schemas, and you can do this in multiple ways, as I will be discussing later. But what's most important is that you can build this data layer in GraphQL without having microservices in GraphQL. You can, of course, bring together GraphQL schemas from your microservices in the data layer, but it's not necessarily something that's that needs to be done this way. So your auth service can be in REST, your user service can also be in REST, your post service can also be in REST or GraphQL. It doesn't really matter, because this data layer or gateway, this will really be the place where you bring together all these microservices. And I especially like a setup like this because not every service is utilized best using GraphQL. So, an example, the auth service, it could be easier to just build it in REST because maybe already some team built it in REST and it's a legacy project. Or maybe one of your teams doesn't like GraphQL or has no experience with it. Or maybe you're investing in some third party API that you're paying some SaaS company in order to distribute you some APIs. Then it could be really nice if you can bring those together in that data layer without having to rely on an API that isn't built in GraphQL. So merging these things in GraphQL can be done in multiple ways. One of the first ways to do it was schema stitching, and I believe we have someone from the guild in this meetup as well. So make sure to check out their projects related to schema stitching. They have a lot of cool tools in the open source library GraphQL tools. And with schema stitching, it's a good approach, but it is a lot of it takes a bit more coding than the approach we'll be showing later on. But schema stitching is especially nice if you want to have a lot of control about what's going on in all the schemas you try to bring together in a data layer. And schema stitching was first designed by Apollo, and then later on, the guild took over the project, in which Apollo introduced federation, which is another way to bring together GraphQL schemas. It's Apollo has its own implementation. StepZen, which I'll be showing you a demo from later on, also has a federation implementation. And there are more companies that introduce federation for GraphQL schemas. And federation is a way to bring together schemas on the schema level, not so much on the resolver level. And then the third option you could have is remote schemas. And remote schemas is especially nice if you work with third parties or you have a very large organization. So I won't be mentioning these today. Let's focus on federation because that's the most obvious example I can show for this microservices setup. So let's see an example. And for this, I use StepZen. And with StepZen, you can create a GraphQL API based on any data source. So the data source can be a database, it can be a REST API, or it can be a GraphQL API. And as these can also be GraphQL APIs, you can also use StepZen to create this data layer or API gateway for your GraphQL microservices. And even if these microservices are using REST, you can still use this tool in order to generate a GraphQL API for you. And one of the bonus points you get here as well is that it automatically deploys a server for you. So you no longer have to worry about deploying services or making sure that your gateway is available, because StepZen will do this all for you. So especially if you're into serverless and you're working on the front end and you don't want to mess with servers, then it can be really nice to check it out. Also, if you're on the back end, it can make your work a lot easier, because I often see backend developers that don't like to build GraphQL APIs. And with a tool like this, you can have one built for you instead of having to build it yourself. So you can still use all the REST APIs or any other APIs that you created and build GraphQL on top of it. So what does it look like? Go to a code example. Clean this terminal for you. Let me just clean all this for you too. So what I've done, I've created a small example project. Maybe make this a tiny bit bigger. People with bad eyes. And so what I've done here, I've created the most simple microservices setup you can have. So I created just a JavaScript project. It's a package of JSON. I'm not doing that much. I'm just creating a start script that will start 3 different microservices. So I've built microservices with probably with JavaScript, but I should have built them in TypeScript. But I've built some JavaScript microservices, and these microservices will all have their own endpoints. So we have the authorization microservice, the post, and the users one. So these are just the ones that you saw in the slides before. So let's have a look at the authorization endpoint. And in order to build these, I've used a tool called JSON Server. And with JSON Server, you can create a REST API based off just a JSON file. So this auth file, It's not really relevant. It's not using a JSON thing. So what we're doing here, we have this auth file, and what it's not using the JSON because the only thing it does, it's actually creating a token for me. So this microservice will create a token for me that I can use in order to send requests to any of the other microservices we have. Let's try and start this thing up. Just here and start. Now it will start all my individual services, and it will also make them available on an external link, because StepSend only works with endpoints that are available to the internet, so you can't use it for your local development because it already deploys a server view to the cloud. So it should know where it can find these endpoints. And so our user service will be available on this endpoint, or post service there, or out service there. So these endpoints are the ones you can also use to connect with your microservices. So if you want to request a token, you should send a request to the out service that runs on this endpoint. Same goes for post and services. So what I've done here, I actually built a GraphQL API for any of these services. So we have an authorization service. There's a type called auth. It has an ID and an access token. And it also has one query, which will return the access token, of course. And this query will send a REST. We'll send a request to a REST endpoint, which is this one. So basically, it will be using the client credentials method of OAuth in order to get a token. And these client credentials are my user environment, so I have them stored somewhere, probably in this file. Yeah. So this file is where I put all the configuration for StepSend. So these are all the different services. Just fill them in. So I'm using local tunnel for the service, by the way, which is quite nice because you can use it for free. So what it does, it actually creates a port for my local environment. You can see I have all these things running on different ports. And then it will just create an endpoint that I can access in the browser or through the internet, through any other tool. Just paste this host names. We will have a user service, which is this one. We'll have a post service, which is this one. Here. And we will have a authentication service, which is this one. Save that, and then I should create a separate terminal. Version for you and clear this up. And then I can just run and start. We'll create the GraphQL API for this for these microservices. See, I need to upgrade, so let me do that in the background. So what are we doing here? And I will get back to the example shortly. So what you need to do in order to use or to build this data layer for your microservices, the first thing you do is create a schema for every microservice, unless they already have GraphQL. So if you're not using GraphQL for your microservices, make sure to create a schema for every microservice. And this can just be a GraphQL file, because the way StepSend parses them later, it only looks at GraphQL schema design language. So every microservice will get their own graph or their own schema. And then we can merge them together with just GraphQL schema design language. So I'll be showing you that in a bit. So let me quickly peek. Yeah, so this is updated. Start the service. So now it will automatically deploy a data layer that I've built for these three things. And then it will automatically deploy this thing here. So what it does here, it already has my my queries that I have. So that is query to get a token. So what I could do is do something like query token access token. This will get me an access token, and then of course I have schemas for I have schemas for all the other services as well. So I have my post services, which has a query to get all the posts in there. And this is all based on a REST endpoint that was created by my microservice. And I will share the link to the example later on. So what we could do here then, we can take this token, and then of course we can also request some posts. We should provide an access token, which is this one. Open the terminal, copy it, this, and put in a title. And then as this is OAuth, I probably need to append mirror to it as well. A little bit. Maybe I shouldn't add mirror. This will get me all the posts from my microservices. But the neat thing is you actually want to combine this because you don't want to retrieve a token every time from your query before you actually get stuff from your microservices. So one of the cool things you can do with StepSen is you can actually use custom directives in order to combine multiple GraphQL schemas. If I would go here, no, actually we look at the post. If I go here, so we have something called a custom directive called a sequence. And in a sequence, you can do multiple queries in a certain combination. So you can first do the query to get a token, which I showed you on the GraphQL editor. So it will first get the token, and then it will use the output of this query as the input for the second one. So the second one is a query to get all the post information. So what I can also do then instead is something like this. I can posts, do anything else. I just need to say I will get the title, this. And now what it does under the hood, which you don't see as a consumer, it will first get the token, and then it will use the output of the token request in order to distribute the token to the post query. So this way you can hide a lot of business logic from your microservices and also create a data layer that combines all these different schemas into one schema. And this data layer is truly where the magic happens. So if you already have APIs or microservices in this case that are using GraphQL, you can already combine them in the data layer. If you don't have GraphQL schemas for your microservices because they're using REST, they're using something else, you can still create those GraphQL schemas for them and merge them together later on. And then the neat part here is also that you can deploy them serverless without having to write any pipelines. So if we will go back to the SDL, we'll have here. So every time you will make a change, so let's suppose we, I don't know, maybe add a line here and save it. You can see a file has been changed. It will start deploying to StepSen, and then a new endpoint will be available. So in our IDE, this would still work because the endpoint is still the same. So this is an endpoint for my account. But from your local environment, you can make changes, and then these will deploy to the cloud automatically. So you no longer have to worry about building any pipelines or making sure things are correct. And the cool thing here is, of course, GraphQL has a type system. The type system here is added in compile time. So if I would be adding stuff here that doesn't exist, so maybe I'll add something like a new field, and let's say this is an integer. Probably I will get an error here somehow because it will need to find this new field. And if this new field hasn't been specified somewhere, it will be catched on compile time. So one of the nice parts here is that you don't have to worry about the GraphQL type system as soon as you deploy things, but instead it will be done during this compile times. And also this is not compiling probably, or it did compile and it can find this one. So these are interesting things to play with. So the neat point here is that the type system is also integrated while you're deploying stuff. So you can be fairly certain that you won't be giving any runtime errors to your users. IDE. Yeah, so deploying them serverless is one of the added features you will get. And then I think we almost killed the half hour. So what you can see here is the GitHub repository, or actually the organization in which you can find these examples. If you would look here for something called Microservices, you will find the actual project I just showed you. And then in order to run it, I think it's in the README. Just double check. Yeah, so make sure you create a StepSend account, you run yarn start. You need to run yarn install actually before. So let me just type it like this. Make sure to also install the dependencies because it's using local tunnel in order to create those deployed endpoints for the microservices. And also it's using JSON server, which is a library to create REST API endpoints based on a DB.json file, an example, which makes it really easy to mock services if you don't have them live yet. And then make sure to run it. It will create the deployed endpoints for you. And then it will just ask you to put it in the configuration.yaml. So that way StepSend can reach them over the internet. As I said, it's being deployed serviceless. So it doesn't work with any local running endpoints. Instead, make sure to make them available on a local tunnel. And also it has some mock credentials, which you don't really have to worry about. It's just an implementation of OAuth. And then if you would to, change your own microservice into this, and make sure to have a look at all these different GraphQL files, and also this data layer file, which brings everything together. A bit short on time to explain all the details in here, but the documentation is pretty concise. And maybe we have some time in the Q&A later on. So with that, I'd like to thank you. Make sure to follow me on Twitter if you have any extra questions you maybe not have time to ask today, or if you have any personal questions you'd like to ask, then Twitter would be a good place to start. So thanks everyone, and then hopefully you have some nice questions for me in the QA.
Thanks, Roy. That was some good stuff in that presentation. I can speak from experience. It's always a pain to deal with like multiple API endpoints on the front end. So having a single place to get all the data from is much better. Plus it makes the caching easier. Okay, so let's see if we have any questions. So the first question would be, how do you deal with temporary service outages? For example, if you have query that requires the token from our service and the service is temporarily unavailable.
Yes, so that is you will handle it in the same way as you would do with any gateway. So if you can't get a token, then your service is unavailable. So you either need to serve cached results, which can be tricky because maybe someone is sending an invalid token and is trying to hack your system. So in general, I would say not return any data. And there are some custom directives in order to tell GraphQL what it should do. So if you have the sequence custom directive that I showed, it will take a number of queries and use the inputs for each other. If something is failing there, you can just revert to something else and then probably return an error object to someone, because I believe we're using mostly error objects in order to return error. So it should be the same as with any gateway, unless you want to take the risk of serving cached results.
Cool. Thanks. Let's see if we have another question. Okay, so another question from Michał. Is there a caching mechanism under the hood?
Yes, definitely. So there are multiple caching mechanisms. So it will automatically cache all the results unless you have any secrets in there. And also it will cache results whenever you're doing. So in GraphQL we have data loaders, and if you're using data loaders in your server you built yourself, it will help you cache results when you're have to call reservables multiple times. So StepSend is doing the same thing. So whenever you're calling a database table multiple times or a REST API multiple times within the same query, it will also implement caching there to help you not falling into any n+1 errors, or not really errors, but n+1 inefficiencies, making sure you don't do any extra calls to either endpoints or databases.
All right. Do we have any more questions? Okay, so it looks like that would be it. Thank you, Roy, very much. Very cool presentation.
Yes, thanks, and looking forward to the next talk. So I believe Arthur is also doing a talk about microservices. So
Yeah.
if you like this talk, stick around.